Alright, so good everybody. I welcome you back to Ajaks Tutorials YouTube channel. My name is Ajaks, see Ajaks Tutorials, and now in today's video, we're going to be looking at friction in a horizontal surface and incline. Now, please, I want to inform you, every single second of this video is very important. Alright, I'm going to dismantle friction from the beginning down to incline problems. Now, we're going to be looking at the definitions of friction. We're going to look at the types of friction and the formulas that's necessary for you to know. We look at the friction on a horizontal surface, friction on an inclined surface. Under friction on a horizontal surface, we're going to solve 10 questions. Under frictions on an inclined plane or an inclined surface, we'll solve what? 10 questions altogether. Okay, no, this is 8 and this is 10. Altogether 18. Then I'll give you 2 as an assignment to drop in the comment section. See, if friction has been your problem since secondary school, just count yourself lucky, because in these video tutorials you're going to learn every single thing about friction in a horizontal surface and an inclined plane. Let's get into the video.
Ajaks Tutorials is more than just an online tutorial. It's a community built on innovation, hard work and excellence. Ajaks Tutorials has consistently set the pace for academic success, tripling her records every year and guiding countless students into their dream institutions. In 2024, Ajaks Tutorials produced 75 students with 300 plus, with the top students emerging 9th nationwide. In 2025, the number soared to 238 students with 300 plus, with the top students ranking 8th in Nigeria. And in 2026, Ajaks Tutorials is set to do even more. Through well-structured online classes, expert tutoring and personalized support, Ajaks Tutorials is redefining quality education. Ajaks Tutorials is headed by Ajakaye Joseph Oluwaseun, the CEO founder and a passionate educator and educational consultant, along with his powerful team of seasoned tutors. To be part of the next success story, contact us via the number displayed. Join Ajaks Tutorials today.
Alright, so welcome back. Now, very quickly, let's start. What is friction? Okay, so I basically want you guys to write and make sure you're using your headphones or your earpod. Alright, now, what is friction? Please write it. You're going to see it on your screen. Friction is a contact force that opposes the relative motion or attempted motion between two surfaces in contact. We're going to do a lot of things. Just note that down. Okay. Secondly, we are done with this first guy. Friction is that contact force that opposes the relative motion, all right, between two surfaces in contact. Now, when something is a contact force, we have contact forces and we have non-contact forces. Gravitation is a non-contact force. They don't require to touch you before it can be effective on your body. But friction needs to be in contact with another surface for it to happen, for it to oppose motion. All right. So friction is that contact force that opposes the relative motion, all right, of a body. Now, let's look at the next aspect, which is the types of friction. Please, I want us to write. I'm putting this thing on our screen so that we can see it and just jot down very quickly. Okay. Now, types of friction. We have the static or limiting friction, which is Fs. Fs is the static or limiting. This is meant to be or rather, or limiting friction. Then we have the Fk, which is the word dynamic. All right, dynamic or what class? Kinetic friction. Now, these two kinds of friction, they are very important. I'm going to explain what it means. Now, let's start with static. Now, when you say something is static, static means at rest. Okay, so when you say static or limiting friction, it's a friction that occurs when a body is in contact with another body and that body is at rest or just about to move. Now, your JAMB examination, WAEC examination, any exams you're preparing for friction, there's something you need to understand. When they say this body is just about to move, that doesn't necessarily mean the body is moving. I hope that makes sense. So now let's establish that anytime you hear a body is just about to move, that still means that the body is at rest. And the frictional force that correlates with a body just about to move is the static or limiting friction. And the frictional force that correlates to a body at rest is still what? The static or limiting friction. I hope that makes sense. Now, secondly, dynamic or kinetic friction. Now, what does this mean? This basically, you see it on your screen now. It occurs when an object is moving, sliding, or rather, you can say when the object is in motion. That is what? Dynamic or kinetic friction. Now, what this basically tells us that if a body is in motion, if a body is sliding from an incline, the friction present there is what? Kinetic or dynamic. I hope that makes sense. Now, let's establish one last thing, then we start solving. Let's establish one last thing. And what we are going to establish now is frictional force. Class, you must understand something. If you want to be able to solve any question at all in friction, you must understand that the frictional force is that particular force that opposes motion. Now, if I am walking like this, I'm walking forward. If I move forward, there is a frictional force that is opposing me. And if you are going like this, what is the opposite of like this? Like this. So, this force going like this is always known, listen, it's always known as the F applied. As the F what applied, the applied force. And any force that opposes this F applied is known as what? The frictional force. Now, we are building foundation. The frictional force. Now, we are building foundation. Now, having established that, there is something I need to tell you that your JAMB examinations or where I can ask you. Now, pay attention. You need to understand that mu K, this is what we call mu K. Mu is basically what we call coefficient of friction. Now, we have two kinds. We have the coefficient of static friction and we have the coefficient of dynamic friction or kinetic friction. Now, the mu K is the coefficient of kinetic friction or dynamic friction, and this friction is responsible for a body in motion or a body sliding from an incline. So when you hear that this body is in motion, all right, the coefficient of static friction that you need, the coefficient of friction that you need is what? Mu K. I hope this makes a lot of sense. Now, mu S is the coefficient of static friction, and this correlates to a body at rest. Now, there's something you need to know. Note that mu K is less than mu S any day, anytime. All right, mu K is less than mu S. That is, the coefficient of kinetic friction is always less than the coefficient of static friction. This is the point you should jot down in your book. Now, let's establish some things. In your examination, they can ask you some theoretical questions in friction, okay? So let's look at some of them. Firstly is this one. They will tell you the kinetic coefficient of friction, is it less than the coefficient of friction for static? Yes, it is less than. Now, there's also something you need to know, that the force, the frictional force, is directly proportional to the normal reaction. Write that down. The frictional force, I will do a lot of things, just chill. The frictional force is directly proportional to the what? Normal reaction. Now, we have established those two important theoretical knowledge on friction. Now, let's get to something very interesting. We are done with types of friction. So, anytime we are solving a question and you see me use mu S, that's coefficient of static friction, it's basically because the body is at rest or the body is just about to move. Then if you see me use mu K, it basically tells you that the body is in what class? Motion. I hope this makes a lot of sense. Now, we have established these two things. Let's start with formulas. Let's go to the next screen. Let's start with formulas. Now, these formulas, I want you to write down in your book. Write it down in your book. Everything I'm saying here, I said every second of this video tutorial is important. Okay? And if you miss one, if you skip one, you might have missed an important JAMB potential point. All right, let's go. The formulas that you need in friction. All right, so now consider a body. So we want to start with the important formulas you need to know. And this is how I'm going to break this video. I'm going to give you formulas under the horizontal surface. Then I'm going to give you a formula. Then we will solve questions. Then after that, I'll move towards incline so that you guys can understand. Now let's start. Consider a body at rest on a surface, on a horizontal surface. Let's say a horizontal rough surface. So let's say this surface is rough. All right, on a horizontal rough surface. So this is my horizontal rough surface. So horizontal surface. Now, pay attention. Pay attention. And, you know, when we are talking about friction, there is an important formula you need to know. And this formula is this. I will state, just pay attention. If this particular block, all right, of mass, if the block is moving towards this place, you know, the block is at rest. Now let's establish that the block is at rest. But there is a force that is pushing this thing like this. Now, class, any force that is responsible for pushing this forward or responsible for its motion is known as what? The applied force. And initially, I told you that anything that opposes the applied force is what? The frictional force. So if this body, this block of mass, if the block of mass is moving like this, there will always be a frictional force to oppose it. Fr. Now, we are going somewhere. Pay attention. The question can ask you, what is the net force? Class, very simple. In friction, note this formula always, that F net is always equal to the applied minus the frictional. This formula, we are going to use it every question. We're going to use it to solve every question. The concept of this formula is exactly only what you need to know in friction. Now, the applied minus the frictional. Now, this frictional is basically what opposes the applied. So, if you have a horizontal surface, the body is going like this. Where will frictional go? Like this. The frictional force is responsible to oppose the motion of the body. Now, let's establish something very interesting. We have established that F net is equal to F applied minus F frictional. Now, there's something else you need to know. Let's put this formula here. And let's clean this horizontal, because I want to do something now. So let's put this formula here. F net is equal to F applied minus F frictional. Now, if this block, you know, there's what we call weight and there's what we call a reaction. Listen, a weight is a downward force. Reactions are what? Upward force. I told you guys when I was teaching you equilibrium of forces. Yes. Now, this block has a weight that goes downward. Weight. And for every weight, there must be a reaction upward. Reaction. Now, note if the surface is rough, the coefficient of friction is present. Coefficient of friction is present. But if the surface is smooth, or sometimes the question can tell you perfectly smooth, know that my coefficient of friction, whether static or dynamic, is 0. So this is a JAMB question or a Y question that you need to know, that in a smooth surface, in a perfectly smooth surface, the coefficient of friction there is what? 0. Now, the first formula you need to do from this particular one here is this formula, that F net is F applied minus F frictional. after that, we need to be able to, let's now establish what frictional force is mathematically. If you remember in the beginning of this video, I told you that the frictional force is directly proportional to the normal reaction. I told you. Now pay attention. Note that Fr, which is the frictional force, is always equal to mu r. Now this mu, it can be mu s, it can be mu k, depending on whether or not this body is moving. So Fr, that's the frictional force, is equal to mu, which is the coefficient of friction, and R is the what? Normal reaction. Now, there's something I need to know. A lot of things to know. Now, you see this normal reaction guy, it changes depending on how the question is modeled. In this question, since we already know that the frictional force, the net force is F applied minus F frictional, then normally if they say, okay, a block of mass was pulled with 5 Newton, all right, find the frictional force if the net force is 12 Newton. So net force is 12 Newton. So net force is equal to applied minus frictional. So applied is 5 minus frictional, we don't know. So now frictional is what? Frictional is what? Okay, this is this minus this. No, net force is not meant to be big like this. If the net force is 3 Newton, okay? So this is going to give me what? 2 Newton. So it means that my applied force, my frictional force is 2. Now, what if they did not give you net force? What if they did not give you net force? Now, the formula that you need to know for Fr in a body that is at rest, on an horizontal plane that is rough. So if the horizontal plane is rough, it means there is friction, right? And if the body is at rest, it means that the acceleration is 0. So a body at rest, acceleration is 0. Don't forget that. The acceleration is not moving now, Abi. Now, Fr is equal to mu r. This thing. Now, what's your R? Your normal reaction. Class, you can clearly see that this R is an upward force and this W weight is a downward force. Class, from resolution of forces, we can tell that if a body is at rest on an horizontal plane, then R is equal to W. What's W, class? The weight, mg. So R is mg. So that's why you always see that frictional force on when the body is on horizontal is equal to mg mu mg. So mu mg is frictional force. Don't forget that. Mu mg. Now, we are getting somewhere very interesting. I want you to pay attention. Please pay attention. Pay attention. You'll be extremely happy with yourself if you can follow this video to the end and listen to all I'm saying. Now, we have established that for a body at rest, the acceleration is 0. Right? Now, let me tell you something. I told you that F net is equal to F applied minus F frictional. Then I'll tell you. Now, note that F net is MA. F applied minus F frictional. So, what's my MA? Mass times acceleration. C equal to F applied minus, what's your Fr? I already told you Fr is mu r. This formula is what you need to know in friction. Jot this down in your book now. Jot this down in your book. Anytime you are given a question and the body is at rest, it basically means that A is 0. So if A is 0, this whole thing is cancelling. Then your F applied will now be equal to what? The F frictional. That's mu r. Another formula to note. Now you use this formula when the body is, listen to this. I've finished explaining this guy. Now listen. You use this formula when the body is at rest on a horizontal surface that is rough. You use this formula when the body is on a horizontal surface that is rough, not at rest, because we need acceleration. I hope this makes sense. Now, let's see questions. Then you guys, all what I'm saying will now start making sense to you. But always note that your normal reaction R is not always equal to W. Your normal reaction R was equal to W here because we resolved. And we saw that the sum of upward forces must be equal to sum of downward forces. Therefore, R is W. We are going to solve a lot of questions and you'll be seeing different kind of R. So all you need to know is this. That the net force is equal to the applied minus the frictional. Anytime you are given a friction question, just know that, okay, my net force is equal to my applied force minus my frictional force. And the applied force is what is responsible for that motion. All right. That means if they tell you that a body was pushed with a force of 10 Newton, that force of 10 Newton is the applied force. Then there will always be a frictional force to oppose that 10 Newton. That's what? Fr. And they'll tell you the acceleration. If they tell you body is at rest, just know this acceleration is what? 0. I hope this makes a lot of sense. Now let's solve questions quickly. All right, so now welcome back. Now let's look at question 1 very quickly. So question 1 will appear on your screen now. So we want to solve questions, 10 questions on horizontal. And remember, all the formula we have established, we established that in a horizontal surface, all right, when the block is resting on an horizontal surface, we have established that my arrow, that's my normal reaction, is equal to W, right? And R is mg, because W is mg. We have also established that F net is equal to F applied minus F frictional. And I told you that this frictional guy, Fr, is equal to what? Mu R. Okay? Now, let's solve a question. Question 1. A force of 20 Newton applied parallel to the surface of a horizontal table. Now, please let me tell you something. If they tell you that a body is resting on a frictionless plane, it means that my coefficient of friction here is 0. So frictionless means there is no friction. Okay? Now let's continue. I just forgot and I had to chip that in. Now, a force of 20 Newton applied parallel to the surface of a horizontal table is just sufficient to make a block of mass 4 kg move on the table. Now, when they tell you it's just sufficient, that means it's just about to move. I told you initially that just about to move does not mean it has moved. Do you understand? Now let's represent this question on a diagram, but we won't be doing this often. I just want to do it for the first few questions so you guys can understand. So you have a mass, a horizontal surface. So this is my horizontal surface. Now, they said a force of 20 newtons applied to, so this is a block here. This is my block. All right, and the block is of mass what? 4 kg. So the mass is 4 kg. It means that my weight is what? 4 times 10 mg now, Abi. That's 40 Newton. That's my weight. Now, calculate the coefficient of friction between the block and the table. Now, they tell you something that they said that this particular block, there was a force 20 Newton applied parallel. This means of parallel. When something is going like this and that thing is going like this, these three things are parallel to each other. So that's means of parallel. So the force that is parallel to make this block about to move is the applied force. You are pushing it with the force of what? 20 Newton. Now, what the question say? Calculate the word coefficient of friction. Are you getting it? Now, we have to calculate coefficient of friction. Coefficient of friction is mu. Now, follow me. I want to explain something. Class, if we want to solve this question now, they told you that the block is just about to move. This coefficient of friction that we are calculating, is it static coefficient of friction or dynamic? Tell me in the comment section fast. Don't pause the video and tell me. Okay. Now the answer is what? Static. Because it is not moving. So it is static or limiting. Okay, I hope that's established. Now let's continue solving. So what I tell you the formula is that my net force is equal to my applied force 20 minus my frictional force FR. Are you following? Now I also told you that this net force is MA, right? And this is equal to 20 minus what's my FR? We don't know yet. Abi? Now, they told you that this, if I were looking for static friction, so it means that this body is not moving. So if it's not moving, it means my acceleration is what? 0. I told you, right? So it means this guy is 0. So this whole thing, if it's 0, this whole thing is cancelling out. So unless it's 0 is equal to 20 minus what? FR. Are you getting it? Now, bring this thing to this other side. We are having that 20 is equal to what? FR. It means that my frictional force, FR is equal to 20 Newton. Now, if my frictional force is 20 Newton, the question says, calculate the static friction mu s. Now, what did I tell you mu s is? FR is equal to mu s multiplied by what? R. And what's my FR? 20 is equal to, class, what's my mu s? That we're looking for, right? And what's my R? I told you that the arrow, when the body, because this is the block, my arrow is normal reaction, it always appears upward. So this is my arrow. So the only force that, when we are resolving this in vertical component, if you guys don't know how to resolve forces, you can check my videos on Lami's theorem. I'll put it on the screen now. Okay, so check it out when you're done with this video. Now, if you want to resolve a vertical force, this thing now is up and this is down. From resolution of forces, the sum of upward force equal to sum of downward force. So it means my reaction is what? My weight. So just know that always when the block is resting on a horizontal surface, just know R is equal to what? W. That is very important. So it means that my R is what? 40. All right. So mu s is equal to what? 20 divided by 40. Class, what's my mu s? My mu s is finally what? 0.5. Good. Now, from my option, option C is correct. Good. I hope this makes a lot of sense. So that's basically how to solve questions on friction. We have a lot of things to do today. Just chill. Okay? So we are done with this first question. Now let's solve question 2. So I hope you understand. It's very simple. First things first, just know that, okay, this F net is equal to apply minus frictional. After that, you know that MA is equal to 20 minus FR. And the acceleration is what? 0. You are done. Now let's move to question 2. Okay? Now let's look at question 2 very quickly. Question 2 will appear on your screen now. And it says, a metal block of mass 5 kg lies on a rough horizontal platform. If the horizontal force of 8 Newton is applied to the block through its center of mass, just slice the block on the platform, just English. Then the coefficient of limiting friction between the block and the platform is. So, class, the coefficient of limiting friction is still the same thing as the coefficient of what? Static friction. So, when I was giving you types of friction, I said static or limiting. Alright, limiting basically applies to when the body is just about to move. But static is when it's at rest. But they are still the same principle. Okay? Now, let's put this in diagram. We will not always be drawing diagram, and I'm not saying you should always be drawing diagram in your JAMB examination. You waste your time, but it's very necessary you actually picturize what you're solving so that you will not be able to make mistake if you do that. Now let's just look at it very quickly. So this is my block. It rests on a surface. All right, it rests on a surface. So what's my block? What's the mass? 5 kg. And if it's coming down, there's a weight down here, and this weight is what? 5 times 10, 50. So 50 Newton. Okay? Now, don't forget there's a reaction. There is always a reaction up. There is always a reaction up. Always. So, if the horizontal force of 8 Newton is applied, that's my applied force. No much English. Applied force. F applied. Okay? Now, what's the coefficient of limiting friction? So coefficient of limiting friction is still the same thing as mu s. Okay, so is it that limiting or static? But if it's dynamic, it's either dynamic or what? Kinetic. So, all right. So this is what? Frictional force, Fr. Now, what again? What are we looking for? Don't forget that this one, they told you is what? 8, right? So this is my 8. This is 8 Newton. So don't forget that. So let's just go very quickly. And since it is limiting or static, it means it is not moving. You know, let me not rush you. So let's go. F net is equal to F applied minus F frictional. What's my F net? F net is ma, right? That's mass times acceleration. What's my F applied? 8. What's my FR? We don't know yet, right? So since this is resting, since it's limiting, it means acceleration is 0. So this is 0 equal to what? 8 minus FR. Take this to the side. It means that my FR is what class? My FR is what? 8 Newton. Now, if FR is 8 Newton, from FR is equal to mu capital R, which is this R is the normal reaction. Don't forget. This is my normal reaction. Normal reaction. Right? So normal reaction. So my FR, which is 8, is now equal to mu. So this mu is what? Mu s. That's limiting frictional force, right? Coefficient of limiting friction. So that's mu s. Multiplied by what? R. And the R is still the same thing as the weight, which is 50. So class, what my mu s be? Mu s will be what? 8 divided by 50. And what will it be finally? Press your calculator. Fast. 8 divided by 50. That's 0.16. And from our option is correct. So how this makes sense? Very, very simple. Okay? Very, very simple. Now, let's look at question 3. So question 3 says, a body, a 100-kilogram box is pushed along a road with a force of 500 Newton. It's pushed with a force of 500. Listen, if the box moves with a uniform velocity, it don't happen. Now, if the box moves with a uniform velocity, class, I already made a video on rectilinear motion. Is on the screen. Go and check it out after this video. And in this video, I established that when the velocity is uniform, class, what happens? The acceleration is 0. So if they tell you that with a uniform velocity or constant velocity, is still the same thing as saying the acceleration is 0, and this is still the same thing as saying the friction is what? Static. It is not moving. Okay, good. So let's use this diagram to do a picture. So question 3, the block of 100, so this is now 100. So this is 100 kilogram. So this is 1000 for the weight, 1000 Newton. We know now 10 times 10, 100 times 10. Okay, so now the force here is 500 Newton. If the box moves with a uniform velocity, so it means in this particular question, my acceleration is 0, just like others we have been solving. Okay, with a uniform velocity, the coefficient of friction between the box and the road is 0.5. So they already told us that the coefficient of, okay, I don't know the answer already. Okay, so we're looking for mu s. So the coefficient of friction between the box and the road. Now, is it a static friction or a dynamic? It is a static, because they told you that the body is of uniform velocity. That means the acceleration is 0. So it means it is not moving. Okay, let's solve. F net is equal to, what's my F applied? 500 minus, what's my FR? We don't know yet. F net, this is 0. Let's just go straight to the point. 500 minus FR. So all our scenario is giving us FR as what? 500 Newton. Now, we have gotten FR as 500 Newton. What else can we do? We just basically say FR is equal to mu s times the normal reaction. So mu s is equal to what? FR divided by normal reaction. So what's my FR? My FR is 500 divided by 1000. Normal reaction is 1000. Now, do you understand? Normal reaction is weight. We have done this before. So 500 by 1000 is 0.5. Yeah. And from the question, option A is correct. Okay, now let's look at the next one. Question 4. You see it on your screen now. This is question 3. Now, question 4 says, what is the coefficient of static friction between a load of mass 2 kilogram and a horizontal surface if the limiting frictional force is 10? Now, they already give us the limiting frictional force. Class, the limiting frictional force is the same thing as frictional force, but the reason why they put limiting there is because they are trying to tell us that this body is not moving. Okay, so my FR, which is my limiting frictional force, is directed us, so we don't need to find it. That's what we have been doing before. We'll not get here. We'll not solve again. No, they have given us. FR is what? 10 Newton. All right. So my mass is 2 kilogram. Since this body is resting on the block is resting on the horizontal surface. All right. It basically tells us it's resting on the horizontal surface. So it tells us my normal reaction is same thing as W, and this is what mg, and this is what 20 times 10, 20 Newton. Okay, 2 times 10 rather. Now, what's my FR? My FR is 10 Newton. So my reaction is 10 Newton. So we can get frictional force from here now. Abi? The limiting what's the question of static friction? So mu s is equal to, so you know mu s is FR divided by what? Normal reaction. This means to be smaller, anyone. So this is what's my FR? 10. And what's my normal reaction? 20. Is what? 0.5. Option A is correct. The same thing. So I hope this makes sense. I hope this makes a lot of sense. Okay. So from question 5 to question 10, you can now pause the video, try it on your own, pause the video, try it on your own, pause the video, try it on your own. Let's move. Question 5.
My name is Bukola Johnson and I had 349 in the 2025 UTME. My experience in the UTME was so beautiful. The classes were very amazing. The tutors, they were very dedicated to impacting knowledge in us. It was truly a very competitive environment. We had bi-monthly mocks. Me that I thought I would be topping it all the time. I even got 12th position. It was so beautiful. My advice to 2026 JAMBITES is for you guys to enroll early so you can experience the full features of Ajaks so you can room properly for the 2026 exam. Wishing you luck.
Alright, so welcome back. Now let's look question 5. So question 5 will appear on screen now, and it says a block of weight 15 Newton. So because of our time, we're going to just be using this guy to do all our question. Okay, so a block weighing 15 Newton rests on a flat surface and a horizontal force of 3 Newton is exerted on it. Determine the frictional force of the block. Okay, so it's simple. So they said a block, this is horizontal surface, right? And the block is weighing what? It is weighing 15 Newton. So that's my weight. So the block is 15 Newton. That's my weight, 15 Newton. My weight. Now, what they say again? It rests. So it is resting. It means my acceleration in this question is 0. So don't ever forget that. It's resting, it's not moving. So the acceleration is what? 0. So it rests on a horizontal surface. It rests on a flat surface. And a horizontal force of 3 Newton. A horizontal force. Horizontal force is like this. So how do I know to put it here? I'll tell you why. 3 Newton is exerted. Applied. Exerted. That's the word applied force. So 3 Newton. Applied force is always here. It's the frictional force that is the bad guy. They're saying no, don't go. It's opposing. Frictional force. Okay? So determine the frictional force of the block. That's what I'm looking for now. Abi? Now, all what we know is going to now come into proper application. For me, what's the first step? This thing should just be in your head. F net, let me clean this W. No waste our time. This thing should always be in your head that F net is equal to F applied minus F frictional. That's the first thing you should write in any friction question out. You guys are going to know why I'm saying this thing when you get to incline. Incline problems is not something you cram. I beg you, don't cram it. You might get confused. Just follow me from beginning till the end. Now, F net is MA. and this F applied is 3 minus my F frictional. Since this body is at rest, it basically tells us that my acceleration is 0. So this whole thing is 0, equal to 3 minus Fr. So class, what's my Fr? My frictional force is what? 3 Newton. That's all. Option B is correct. That's all. Very simple. Nothing else. Question 6. Now, I'm leaving this here so that you can just be going through, be reflecting, we'll soon clean it. Question 6 says, you see it on your screen now, a force 10 Newton. Let me show you this is recording now. A force 10 Newton drags a mass 10 kilogram on the horizontal table with an acceleration of 0.2. Now they are giving us acceleration. That means the body is not at rest. That's why you don't cram. Don't cram. Don't go and say, this is the only thing I've been doing, so this is the only thing I need to know. No. So, this question, the mass is what? 10 kilogram. So, it means the weight is what? 100 Newton. Right? So, it drags it. So, it's here you drag. Now, drag. Fr. If you say, oh, you want to drag like this, no problem. We're not doing it's not issue. If you want to drag like this, just know that you are going in the negative direction in the Cartesian plane. In the Cartesian plane, we have it like this. This is the positive x, this is the negative x. This is the positive y, and this is the what? Negative y. So, better know what you are doing. So, the one guy ask me, sir, why can I not drag it to the left? You are going in the negative direction. Then you have to account for minus. If not, you do physics blunder. Now, so you drag it here, and they told you the force you used to drag it. That's what? 10 Newton. So that's my dragging force, right? Good. That's the applied force, rather. Really? Applied force. Now, so the acceleration in this question is 0.2 meters per second squared. Now, if the acceleration due to gravity is 10, that's g, find the coefficient of friction between the moving mass and the table. So the mass is moving, so we are looking for coefficient of friction, but this is Fr. So class, the coefficient of friction we're looking for, is it F, is it mu S or mu K? Mu K, because it's moving. So we're looking for mu K. Coefficient of what? That dynamic or kinetic friction. Okay, so this is very, very simple. We can actually try this. Let's just go. F nets, let's clean this thing. Let's clean this one so that we'll have more space. So we are still using this guy. That's this formula. F net is equal to, so what's my F net now? MA is equal to, are you following me? F applied. What's my F applied? My F applied is what? 10. Minus what's my F frictional? We don't know yet. Have you now? Good. So don't gonna get confused. This is not the question we're solving. That's this is what we're solving. Okay. Even clean this thing because many of you are funny. Very, very funny. So ask me, sir, that thing is not 3. So what are you doing now? Your eyes blind. Okay, so let's continue. MA equal to 10 minus Fr. So my MA, they told me that my mass is 10 times what's my A? 0.2 is equal to 10. That's my applied force minus frictional force. We don't know. Right? So it means that this thing now is this thing 10 times 0.2 means 10 times 2 over 10. That's 2. If you don't understand why I just say, press the calculator. 10 minus Fr. So bring this here, bring this here. So it's finally bring this one here, bring this one here. So finally my Fr is equal to what? 10 minus 2. And my Fr is equal to what? 8 Newton. Now, we've gotten my Fr as 8 Newton, but the question asks us to find the coefficient of friction. That's coefficient of kinetic friction. Because the body is moving. Why is it moving? Acceleration is 0.2. Do you understand? So my Fr normally is equal to mu r. This is not changed. This never changed. This never changes. But the only thing that might change eventually is your r. Your r differs depending on what the way the question is modeled. I already told you. So in this question, my r is still the same thing as what my normal my r is the same thing as my weight, because we don't have any upward force, we don't have anything like that. We don't have any more upward force, any more downward force. The only vertical forces present in this free body diagram, this is a free body diagram in case you don't know. This is a free body diagram. So the only vertical forces present here are the reaction and the what weight. So my FR is 8 and my mu K multiplied by what's my reaction 100. So mu K is equal to 8 over 100. That's 0.08. Option A is correct. Okay, so let's look at question 7. Alright, so question 7. A body of mass 10 kilogram rests on a rough this is nice. Good. It rests on a rough inclined plane whose angle of tilt theta is variable. Theta is gradually increased. This is question 7. Theta is gradually increased. Let me be sure that what I'm saying is the correct part. I'm in correct segment. 0.53, 0.8. Okay. So it's increased until the body starts to slide down the plane at 30 degrees. The coefficient of limiting friction between the body and the plane is, now, note this thing down, that mu s is equal to tan theta. Now, let me tell you something. Mu s alone is tan theta. Mu s alone is tan theta. Mu s alone is tan theta. Mu k is not tan theta. I will tell you why when we get to incline. I don't want to skip. I'll tell you why when we get to incline. In fact, I will prove this thing. I'll prove why mu s is equal to tan theta. So, note this thing down, that mu s is what tan theta. So, in this particular question, my coefficient of friction, that's coefficient of limiting friction or static friction, are the same thing, is equal to what tan theta, that's tan 30. So, tan 30 is equal to 0.5771, something like that. Let me even tell you something. In your exam, please, I think you guys should learn not just special angles, but learn their values in decimals. Yes. Because look at it now. Tan 30 is 1 over root 3. There's nothing like root 3 in JAMB. Alright? Or you can learn either root 3 or root 2. Root 2 is 1.414. So go and learn root 3. Okay? So go and learn root 3. Let me just write this down for you so just know. Know that root 2, that's the value. Root 2 is 1.414. And root 3 is 1.732. So knowing that tan theta is root 3 over 3 or 1 over root 3, anyone when you rationalize this or this. So we can now say, okay, since my root 3, we can now say mu s is equal to, what's my root 3? 1.732. That's because there's nothing like roots in JAMB. So, but if you're a WAEC student, you can just basically press it straight because of you guys have normal calculator. WAEC is not even CBT. So everyone pay attention. So divide by 3. So this divided by 3, that gives you mu s to be 0.5773. So you can use, and this is approximately 0.58. So the answer is 0.58. Option C. So let me continue to do what I was explaining. Now, sine, let me just digress a little bit. Pay attention. Sine 30 is 1 over 2. Sine 60 is root 3 over 2. Right? Cos 30 is root 3 over 2. Cos 60 is 1 over 2. Tan 30 is 1 over root 3. When you rationalize, root 3 over 3. Write this down. These are special angles. I did it in my videos on equilibrium, but I know many of you maybe you not pay attention. Then tan 60 is root 3. Then sine 45 is same thing as cos 45. And this whole thing is what? Root 2 over 2. Or 1 over root 2 if you rationalize. Okay, so that's it. So you need to just know root 3 value and root 2 value. So now, if in your exam, you are trying to now do root 2 over 2, and all your answers are in decimals. Root 2 over 2, you just basically say 1.414 divided by 2. And you can press your calculator from here. So I hope this helps. Okay, I hope this helps. Now let's look at question 8. Okay, let me clean the board. Now you see the screen now. Question 8 says an object of mass 8 kilogram mass 80 kilogram is pulled on a horizontal rough ground by a force of 500 Newton. Find the coefficient of static friction. So let's not draw. Just know that F net is equal to what? F applied, that's my pulling force minus my F frictional, my frictional force. Abi? So F net now, they said the body is static. So what to look for the coefficient was static friction. It means that in this case, my acceleration was 0. That means since it's static, that means it was at rest. Okay? These things are things we have established before. So this means this whole thing is 0. So equal to, are you following? Equal to F applied. F applied is 500 from the question minus F frictional. So F frictional in this case is what? 500 Newton. Now, if my F frictional is 500 Newton, they asked us to find the coefficient of static friction. Simple now. Abi, what's the mass they gave us? 80. So my mass is 80 kilogram. And we already know that my normal reaction is mg. Do you understand? Free body diagram now. Abi? So this my R is 800. Do you get? So remember, FR is equal to mu R. This never change. Okay? This mu now we're looking for mu S. So multiply by, what's my R? 800. Please put your units. We're students. Okay? Equal to 500 Newton. So mu S is equal to, this give me 500 over 800. So what's my mu S finally? 0.625, approximately 0.6. Option D is correct. Yeah, option D is correct. Okay, I hope this makes sense. So let's do question 9. Question 9 is a bit more interesting. Now, please, if you have not watched my video on rectilinear motion, after this video, please go and pay attention to it. Okay, let's dismantle question 9 here. Now, question 9 will appear on the screen now. It says, when a box of mass 45 kilogram is given an initial speed of 5. Initial speed is u. Nothing is changed. Even if we are doing friction, that doesn't still block your knowledge on rectilinear motions. Okay, so the initial speed is 5 meters per second. It slides along a horizontal floor a distance 3 meters. So my S is 3 meters. Before coming to rest, that means it came to rest. Rectilinear motion, I told you, when the body comes to rest, what happens? My velocity is 0, my final velocity. All right, now, what is the coefficient of kinetic friction? So mu k, obviously, because the body moved, right? The body was moving, so mu k. So the coefficient of kinetic friction we're looking for. Now, let's solve. Abi. So I'm looking for mu k. Now, how can we get mu k? I need to draw this thing here so that the weight of the body was 45. So this the weight is the mass is 45, so my weight is 450. Now then my normal reaction is equal to W. Okay. Then what else? There was something here and something here. So this is my free body diagram. So F applied and this is my F frictional. Okay, not necessary anyways, but let's just draw that. Now, what is the coefficient of kinetic friction? How can we do this? We all know that to find this thing, we have to at least get FR. They will not say FR equal to mu KR. But how can we get FR, class? How can we get FR? How? Now pay attention. This FR, recall that F net is equal to F applied minus F frictional. Are you following? Now, this question, they said, when a box of mass 45 is given an initial speed, it slides along a horizontal floor a distance of 3 meters before coming to rest. What is the question of kinetic friction? Now, they did not give us any information about the applied force. So it means that this guy is 0. Are you getting me? Now, what's my F net? F net normally is MA. And this is equal to minus FR. Now, what is acceleration? You know, the goal is this. Now, what is acceleration? Class, from this whole thing, they gave us U, they gave us S, they gave us V. Class, from equations of motion, the third one, it told us that V squared equal U squared plus 2AS. And my V squared is 0 squared equal my U squared is 5 squared plus 2 multiplied by A multiplied by what's my S? 3. Right? So this gives me 0 and this is equal to what? 25 plus what? 6A. Right? So it means my this is 6A now. Bring this thing here. That's minus 6A is equal to 25. Are you getting it? Now minus 6A equal to 25. Let's continue from here. Minus 6A equal to 25. Now, minus 6A equal to 25. So it means that my A is what? Minus 25 over 6. So this whole thing is in what? Meters per second squared. Let's not, don't be too quick to divide. Just chill. Okay? Now, you can see that stuff is in minus. Class, is in minus because it decelerated. Because it's what? It decelerated. I hope this makes a lot of sense. So, when the acceleration is negative, it means there is what? A deceleration. I told you in the previous video. So, we have gotten acceleration and the mass in the question was what? 45. So, my mass is 45 kilogram. So, from MA is equal to minus FR. What's my A? Minus 25. My mass is 45. Multiplied by minus 25 over 6 equal to FR. Minus FR. You understand? So, minus cancels minus. Multiply these two things. 45 times 25 divided by 6 gives you your FR. So let's solve. What's my FR, class? Finally, press your calculator. Press. 45 times 25 is 1125 divided by 6. So my FR is 187.5 Newton. Now, you have gotten your FR, class. What are we looking for originally? We're looking for what? Mu K. So, FR normally is equal to mu KR. So, 187.5 is equal to mu K times, what's my R? Weight, that's 450. We are done with that guy. So, my R is 450. Okay, so we can now solve now, Abby. So what's my mu K finally? 187.5 divided by what? 450. My mu K is equal to, so 187.5 divided by 450. That's 0.412. 417. And that's my, 417. That's my mu K. But from the options, the answer is actually 5 over 12. Because if you press 5 over 12, now let's press it. 5 divided by 12 gives you 0.417. You understand? So the answer is 5 over 12. But we can get 5 over 12 anyways. We can get 5 over 12. This is correct. We can get 5 over 12 by just normal division. Abi? Just normal division. Just multiply these two things, leave it like that. Do you understand? You know, this thing is 45 here. So it's just let's just do it. Let's just do it so that you guys don't get confused. So we can do that. We just from here. Now you know this thing was FR, right? So this whole thing, FR, you know, we did FR divided by the weight. I mean the normal reaction. So FR divided by normal reaction. So let's go FR divided by normal reaction. That's this whole thing. 45 times 25 divided by 6. So this is my FR. So we are dividing this whole thing by normal reaction. That's times 1 over 450. And this whole thing gives us what? The mu k. So the mu k equal to, do you understand? So 45 here 1, 45 here 10. I mean now, 5 here 2, 5 here what? 5. So 5 over what? 6 times 2, 12. Same thing. So you get your answer. Anyone is fine. Okay. Now I hope that makes sense. That's question 9. Option B is correct. Question 10. To appear on your screen now. This is a good question. The frictional force between two bodies A exists only when there is a relative motion or tendency for motion. B acts as to oppose the motion. C acts on the normal reaction between the two surfaces. D has all the characteristics. Class, option D is correct, because option A, it exists between when there's a relative motion, yes, or when there's a tendency to move. That means frictional force to be there even when it has not moved and when it is moving. That's what option A says, and it's true. B, it acts as to oppose motion. That's the definition of friction, so it's true. 3, it depends on the normal reaction. That's true. I told you the frictional force is directly proportional to what? Normal reaction. Frictional force is directly proportional to what? Normal reaction. Is this mu k that's the constant of proportionality? Are you following? Good. So that's the answer. Now we are done with this first segment. Class, clap for yourself. Clap for yourself. Pa, 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 pa. Now we are done with friction on horizontal surface. Go to your past question and dismantle. Receive it. Go to your past question. Now let's look at friction on an inclined surface. Now this aspect we're moving to, I want you to pay attention, okay? Because I can bet you it is not as difficult as you think. I'm going to explain it in details and I want you to pay attention. If peradventure you have any questions, please just ask me in the comment section. And yes, if you're enjoying this video, do well to like, subscribe, and share to your friends that are preparing for JAMB or WAEC or NECO or post-UTME that are having problems with friction. And like I said initially, my name is Ajaks. I'm the CEO of Ajaks Tutorials, the #1 online tutorials in Nigeria. Text me, this is my WhatsApp number on the screen, to be a part of our paid classes. Okay, let's continue. Friction on an inclined surface.
My name is Aditoro Lawali. I got 362 in JAMB. So at Ajaks Tutorials, actually joined pretty late, so I didn't get to experience the full thing. But the little time I spent was nice. I had a lot of catching up to do since I joined late, but in the end I pulled through. I got a decent score. And for 2026 JAMBITES, I'd advise them not to do what I did. Start early, be disciplined and all that. And yeah, it's all pay off in the end.
Alright, so welcome back. Now, I welcome you back to Ajaks Tutorials. Now, we're going to look at incline problems, free body diagram. That's FBD, free body diagram. Now, let me tell you something. We are going to draw this free body diagram, and I'm going to explain to you why this is this. And now, we're going to now take it step by step. We'll do case 1. When the body is on an incline but is at rest. Case 2, when the body is on an incline but is sliding down. Case 3, like that. Case 4, like that. So I think I have like 4 cases or so. 1, 2, 1, 2, 3. I think 4, 3 or 4. We're going to do everything. Now, when we have done these cases and I explain properly, you will now start solving questions. Solve 8 questions. You guys, you don't need to run anywhere. If you're tired, go and sleep. Come back to this video, because the goal is for you to know frictions. Now, let's start. Free body diagrams. Now, consider an incline. Please pay attention. Let me get my red marker, please. Consider an incline. We're going to use this thing to be solving other questions. So, just like how we did for the other guy. Now, consider an incline. All right. So, consider an incline. I want to make sure this is as accurate as possible, because we need to see it clearly. I think it's okay. Now consider an incline. This is 90 degrees. Never forget that. Now consider that a body, a block of mass, is on top of this incline. Now, class, and this mass, you know, when there is something on top an incline, regardless, there must always be, this is the middle, yeah, there must always be a what? Reaction. Are you following? There must always be what? A reaction. Draw this thing in your book now. And there must always be a weight. Weight acts downwards, reaction goes upward. You cannot draw this reaction like this, because this incline now, imagine you fall this down. See, as like this now, imagine you fall it down. Then this reaction will now come up straight. So we have to draw the incline like this because it is on the incline. But regardless, we must draw the weight downward, straight. So downward. Now, this is the weight. I'm getting somewhere. Now, class, listen attentively. There is an angle theta here. All right, normally an incline to an angle theta. Now, this is the reaction, normal reaction R. This is my W. Are you following me? Class, do you know that if, okay, now let me elongate this thing. So let me elongate it. Now, class, perfect, we're getting somewhere. Do you know that, listen, do you know that if we elongate this thing like this now, do you know that the angle here is still the angle that is formed here? I will explain. I will explain. Pay attention. Now look at this thing. Look at this thing. See, this weight, listen, this weight is perpendicular. The weight is perpendicular to this thing. So it means this is right angle triangle. Are you following? The weight is down. This one is like this. Nothing is changing. Now, class, do you know that this is equal to this? Ajaks, how? Calm down. If, let's say, this theta was 30 degrees. Now, let's assume theta is 30. I want you guys to do the math with me. If theta is 30 here, since this is a right, now look, this thing now, this thing is a right angle triangle. I mean now, so since this is a right angle triangle, it means that this one here will be 90 minus 30, that's 60. So here will be 60. That's here. Now, if here is 60, if this thing, let me do it like this. Hold on. Calm down, I want to get it straight. The weight is meant to be from here. Yeah. And yes, theta. Yes. Now, so if here, this thing is the same thing as this thing. So if here is theta, here is theta. Now, like I said, this was 30. Then this place will be 60. Class, if this thing is 60, and recall that here is 90. Do you understand? This is straight now, so this is 90. This thing is 90. So 90 plus, that's here, plus what is the angle here? We don't know. Plus what's the angle here? 60. Everything must equate to 180 because you're on a straight line. Are you following me? Good. So it means that 180 degrees will be equal to what? Add this two up. 90 plus 60 is 150. So theta plus 150. And what's my theta finally? 30. So can you guys see that this place is the same thing as this place? I hope that is established now. Okay? Now, we have gotten that. We have gotten that this is this. So what is the next thing to do? What is the next thing to do? This is an incline problem. Now, we have to find this component and this component. Cause you guys should just calm down. Don't worry, calm down. It might look confusing, but you'll soon get it. Just be following me, listening. You have to find this component and this component. Now, let us now look at this thing, class. Look at it attentively. Look at it well. You are going to see that this thing here is parallel to this thing. This place is parallel to this place. So anything we are getting here will correlate to this thing here. Do you understand? Anything we get here, it will correlate to what will happen here. That's the component here. So this correlates with this. Are you getting it? And this correlates with what will happen in the reaction. I hope that's clear. Now, let's bring out this triangle. Let's bring out this triangle. Exactly how it looks. This is the right angle, and this is my theta. And this is what? My theta. Now, this part is correlating to this part. This part is correlating to this part. So, let's name this X and let's name this Y. Now, from Sokatwa, if you recall well, you're going to see that this thing here, this W that came like this, is the weight, and that's mg. So it means that this thing is this thing. This place is mg. Okay, this is sine, which is opposite x over hypotenuse mg. Are you following? So my sine theta is opposite over what? Hypotenuse. So my sine, so my x, that's this one, is what? Mg Alright, so my x is mg sine theta. And this correlates to this. Are you following? Now, this is my y. This is my y. Class, this is the adjacent, right? And this is the hypotenuse. Cos theta is equal to what? What's my adjacent? K. Adjacent over hypotenuse, that's y over mg. So what's my y finally? Mg cos theta. And I told you that my y will correlate to what? This one. This tells us that in an incline, note that my R, which is my normal reaction, is equal to mg cos theta. So if finally, we have established that R is mg cos theta, all right, and the component here is mg sin theta. Now, we have established those two things, and I want you to note them down. Now, initially, I told you that mu s is equal to tan theta. Why? Why? Class, if this block on this incline let me just clean everything. Now, class, if this block on this incline is at rest, if the block is at rest, class, what is going to happen? If it is at rest, it means that there will not be motion here. Now, it also means my acceleration is 0. Class, initially I told you that F net is equal to what? F net is equal to F applied minus F frictional. Now, this block now, class, if you place a block on an incline, ideally, where is the block meant to go? Like this. because it's what? Sliding down. So since this is at rest, then this is 0, and this is going to equal to what? The applied force. So it is sliding down. So this will replace the mg sin theta. Minus, there will be a force that opposes this block from going down, Fr. Now, it means my Fr is equal to mg sin theta. Class, I told you that Fr is same thing as mu. So since it's at rest, it's mu s r, right? It doesn't change. Equal to mg sin theta. Now, what's mu? We don't know. Mu s. What's my r? I told you that in an incline, we have derived that r is mg cos theta. Always in an incline. Equal to mg sin theta. Class, m cancels m, g cancels g. What are we left with? Mu s cos theta equal to sin theta. Now, mu s cos theta equal to sin theta. Mu s cos theta equal to sin theta. Class, from SOHCAHTOA, tan means opposite, from trig identity, know that tan theta is equal to sin theta over cos theta. So if I say dividing both sides by cos, I'm going to have that mu s is equal to what? Tan theta. Proved. I hope this makes a lot of sense. Now, let me tell you something about this thing. This mu s is tan theta, and that mu s is the coefficient of static friction or limiting friction. In fact, limiting friction. It can never be mu k, because when we talk about this theta is called the angle of repose. Angle of what? Repose. Now, angle of repose is that maximum angle, all right, that this incline will attain for it to just begin to move. That's the angle of repose. So, the angle of repose will not now take effect if the body is now moving. So, the angle of repose is the critical angle at which that body will be in the verge of what? Motion. Do you understand? Good. So that is why never ever can this be mu k equal tan theta. No, it's always mu s equal tan theta. Now, we have derived a lot of things. You might not just see it now, but I'm going to explain. Now, first thing you need to know is this whole thing I explained. Now, second thing you need to know is this. R equal to mg cos theta. Very important. Third thing you need to know is mu s equal to tan theta. The fourth thing you need to know is in an incline, this down the incline is always mg sin theta. Always. So this is always, and what else? That's all. Now let's take it case by case. Now, I'm not going to do any of this. I'm just going to be giving you the formula that you need to use to solve a particular case. When they tell you this body is at rest, when they tell you this body is moving on an incline, what and what to use, what and what to know. When they tell you your body is pulled, what and what to know. They will not solve questions. I hope this makes sense. Good. Alright, now let's establish some things very quickly, and I want you guys to write down. Please, everything I've actually said before, write it down. So my case 1 is when the body is at rest or just about to move. So when the body is at rest or just about to move, they are saying the same thing. So when the body is at rest or just about to move. Now, what will happen when the body is on an incline but is at rest and just about to move? So when it's at rest, always know that my acceleration is 0, and this tells you that my F net is still 0. And remember, F net is equal to F applied minus F frictional. Okay? So when it's at rest, alright, what's my applied force? Is this guy. This is my applied force. Because it's meant to follow, it's meant to come down like this. So the direction in which the block is going is that where the applied force is. So my applied force is mg sine theta minus my frictional force Fr. Okay, so when it is at rest, this is the formula to note, that mg sine theta is equal to Fr. Some questions will give you Fr, some you might have to use that. You might now further go that say mg sine theta is equal to mu mg cos theta. That's mu r. R is mg cos theta, but I've established that already. That's my r is mg cos theta. Do you understand? Mg cos theta in an incline, just like how r was mg on the horizontal surface, you know, but in an incline, r is mg cos theta. Okay, so this is the formula you need to use when the body is at rest. So you can, and this one takes you directly to mu s equal tan theta. Yeah, so this takes you, so you either use this one or you use this one, depends on parameters you are given. Okay, now let's continue. The case 2. The case 2 is when the body is smooth but it's sliding down. Smooth and sliding. Now, when a body is smooth and sliding, first of all, if it's smooth, it tells us that there is no friction. Abi? So if the body is smooth, it says it means there's no friction. So now, if it is smooth, first of all, let's establish what the applied force is going to be like. I mean, what's the net force going to be like? Net equal to F applied minus F frictional. Abi? So what's my F net? Normally it's MA. It's sliding, so it must have an acceleration. So MA, unlike this one, the acceleration was 0. Are you getting it? So MA is equal to the F applied, this one, mg cos theta. Please never forget mg sin theta, pardon me. Please never forget this. Please never ever forget it. What's wrong with my phone now? So mg sin theta minus fr. So fr is, now this fr is mu k, because why is it k? It is sliding now. Mu k mg cos theta. Okay, that's mu r now. Mu r. R is mg cos theta. So they told you that it is smooth. So it means that since it is smooth, it means my mu k is 0. So this whole thing is cancelled out. So for a body that is smooth and sliding, the formula I need to know is what? Ma is equal to mg sin theta. And finally, m cancel m. So my acceleration is what? G sin theta. That's all. Never forget this. Okay? Never forget it. So this is the acceleration for a body that is smooth and sliding. This is what I just used. G sin theta. Now, let's look at the case 3. Then we'll look at case 4 finally. Now, case 3 is when the body is rough and sliding. So now, case 3 is when the body is rough and sliding. So it is rough and it is sliding at the same time. So if it is rough, it means there is a friction. Abi? So we'll just say that F net is equal to F applied minus F frictional. Let's divide this into 2. Abi? So my F net means there is an acceleration now. So this is not 0, unlike case 1. Why is it not 0? Because it's sliding. So what's my F applied? My F applied is this one. Minus, what's my F frictional? The one that's opposing the F applied. Okay, they will tell you your question, or sometimes you might not be told. So MA be equal to mg sin theta minus mu k r. Abi now, so mu k r. So in this case, we are having that MA is equal to mg sin theta minus mu k mg cos theta, right? So this whole thing now is when the body is what? Rough and sliding. So let's find acceleration. Now, if you look, we can bring out mass from here. If I bring out my mass from this whole thing, I'll have that mass times acceleration equal to, bring out mass, I will left with what? G sin theta minus mu k g cos theta. Do you understand? So mass cancels mass. So it means my acceleration in this question is what? G sin theta minus mu k g cos theta. So this is when the body is what? Is rough and sliding. Okay? So when it's rough and sliding. Now, case 4, which is the final case. And this case 4 is when the body is... Yes, when the body is being pulled by an object pulled by an object from a slope. Now, let me explain. Pulled at a slope. So it makes an angle theta when it's pulled. Now, this is a very, very important question. And we'll solve question like that. We'll solve question we'll solve a JAMB question on this case 4 in this video. Now, let me explain this thing. I'll draw a diagram here and I will give the explanations there. So this is how it looks like. You have a mass, weight, right? And definitely there must be a reaction, right? So the body normally is meant to go like this. But in this case, it is pulled. It is pulled. So with a pulling force P at an angle theta. Now, what is going to happen? So there's always a frictional force here. Now, how will you solve questions? You know, this is not like the first one. The first rough body, this is a rough surface, right? That means there is friction in between. So this is not like the first one that we do not there's nothing like angle, but this one now there's an angle. Okay, so welcome. I had to clean this guy first. Now let's continue. So it is pulled with a pulling force P. Now let me tell you something you need to know. Normally, this is meant to be the applied. That's this horizontal component here is meant to be applied. But in this case, they did not tell us anything about the applied. All right, they told us a pulling force. So we have to find this applied. We have to find it applied, and we also have to understand that in this particular question or in this particular case, the reaction is not the weight. I'll explain. Now let's look at this very, very closely. Look at it. This block, right? So there is a weight that comes down and there's a reaction that goes up. Now, it was pulled. You pull it with a pulling force P at an angle theta. And this is what we are actually meant to use when we are doing our net force. You know, F net is equal to F applied minus F frictional. So this is the F applied. Are you getting it? So minus F frictional. Now, in this case, pay attention. My F applied is going to be, now when you want to solve questions like this, we're going to solve a question like this in this video. When you solve questions like this F applied is going to be the horizontal component of this P. So that's P cos theta. Note, horizontal component is P cos theta, vertical component is P sin theta. So now this is going to be P cos theta minus FR equal to F net. So we assume that this body there is an acceleration. Alright? So we assume that there is an acceleration, so present. That means it's not at rest. Do you understand? If the tell you it's at rest, just know that this whole thing is zero. Then P cos theta will be equal to FR. So you know, in fact, let's assume this body is at rest. Okay? Let's assume it's at rest. We'll see a question, don't worry. Don't fear, we'll see a question. So let's assume it's at, so if it's at rest, then this P net is what? 0. Equal to P cos theta minus FR. Let's divide this board in case we need it. Okay, so bring this here. So it means my FR is equal to P cos theta. Now, class, pay attention. Normally, if the question gives you FR, you are lucky. Alright? But you need to understand that this part is going to be P cos theta because we have to resolve this P here. So if the question gives you FR, you are lucky. If they don't give you FR, remember, what's FR? Mu S, since it is 0, so it's mu S. Mu SR equal to P cos theta. Now, let me tell you something. The arrow in this particular question, in the first one, arrow was mg. In the incline, arrow is mg cos theta. In this case, arrow is none of those. Now, let me tell you what arrow is. If you look at this thing, why will you resolve for horizontal components without resolving for vertical components? Why now? Why are you stingy? So you have to resolve for vertical too. And vertical component of this p is going to be p sine theta. Are you following? P what? Sine theta, in case my light is stopping. So this is p sine theta. Now, these two are going up. This weight is coming down. Class, upward force equal to downward force. Class, arrow plus p sine theta is equal to w. Now, what will my arrow be finally? W minus p sine theta. So what will my arrow be? Mg minus what? P sine theta. Well, you're done. So it means my mu s into bracket mg p sine theta. Sorry, mg minus p sine theta. So that's my arrow. So in case like this, just know that arrow is mg minus p sine theta equal to p cos theta. That's it. That's all. So this is the formula you need for this case. But you know what? Let me just tell you something. I don't cram formulas. Personally, I don't cram formulas. I am a student that when I'm reading, I try my best not to overload my brain with something that's not necessary. To me, cramming these formulas are not necessary because I can easily prove them quickly. It's because I'm teaching you guys, that's why it's a bit slow. And if you practice well, if you read properly, if you practice, you'll be able to prove all these things. So cramming formula is not really necessary because sometimes now you might mix them up. So please just try to understand what I'm doing. Okay? Now we have done case 1, case 2, case 3, and case 4. Let me review this case 4 again. It is pulling up F applied minus F frictional, which is the normal thing. Alright? In this case, my F applied is my horizontal component. That's M P cos theta minus F arrow. That's this thing. And F arrow normally we know it as what? Mu S arrow. Abi? And my arrow is normal reaction. In the first one, that's horizontal, arrow was mg. Alright? In incline, arrow is mg cos theta. But in this case, arrow is what? Mg minus p sine theta. Because we already explained that arrow plus this p are upward forces, so it must be equal to downward force. That's why. Okay? But that's basically it. So that's why arrow is equal to w minus p sine theta. Okay? So that's it. So this is my arrow, don't forget that. And this is my formula for the answer. So this is when it is at rest. So assuming it was not at rest, it means that this thing will be MA. This thing here will be MA. You understand? This whole thing will be MA. And it's still the same thing, just difference of formulas. Okay, now let's solve question. Question 11. Solve question 11. There's something I want to tell you. You know, I gave you an incline that time. And I told you that this is at angle theta. Then there is a force here. Alright. Then at this point, there is a weight that was down. Okay. I mean now, then there is a reaction arrow. Alright. I told you that at this point here, just draw this thing here. So this point, when you elongate this guy, this is theta. Okay, this and this are the same thing. We already established that. So with this one comes like this, and this is a right angle triangle. Okay, then I said that this thing here, listen, I'm going somewhere, listen. I said that this thing here, this thing is parallel to this thing. So the question is this, JAMB can ask you, the force or the component parallel to an incline is W. You know, we calculated this place as W sine theta. Don't forget that. And W is mg. So mg sine theta or mg cos theta. Mg sine theta or W sine theta is the answer. So the components, write that in your book now. Components parallel to the or parallel down to the down on an incline. Any I won't put English, okay? To the down incline. Let me put that down incline. Is mg sine theta. JAMB question. Don't forget that, okay? And the component that corresponds to the arrow is mg cos theta. Don't forget. So this corresponds to the what? Normal reaction n. or R, anyone. Okay, now let's look at question 6. I said question 6, question 11. Sorry. Question 11 will appear on screen now. A body of mass 6 kilogram rests on an inclined plane. So let's draw this question 6. So it rests on an inclined plane. We will not do all these things. We have done it already. We'll just go straight. So the body of mass 6 kilogram. So it rests on an inclined plane. It rests on an inclined plane. So the inclined plane, the normal reaction is R. So my normal reaction is R. It's good to know how to draw this diagram. It will help you. Like, it helps your knowledge on friction. So don't try to start skipping the diagram. Try to know how to draw it. So this is the weight, and this is 60 Newton, right? Mg. Then this is my theta. Okay. So the normal reaction and the limiting frictional force. Now, the limiting frictional force is the frictional force that opposes the body from going here. So the limiting frictional force is here. FR. Still the same thing, just English. Abi? So it's shown, all right, if F, that's what I just drew here. If F is 30 Newton. So if F is 30 Newton. So the limiting frictional force is F. So this F now, they told you is 30 Newton. That's what it means. So if F is 30 Newton and G is 10, so my acceleration due to gravity is 10 meters per second squared. All right. The angle of inclination is, so this is the angle. All right. So the angle of inclination, that is very, very simple. Okay. Now we already know that down the incline here is mg sin theta. Like this should be common knowledge now. Mg sin theta. Okay, this is an arrow. Mg sin theta. So how can we do it? Now listen attentively. They said a body of mass 6 kilogram rests. If it's rest, it basically means my what? A is 0. And if A is 0, this was the case 2 or case 3, anyone. I shall know I gave you. Alright? When it's at rest, okay? When it's at rest on an incline. So what do? Firstly, F net, this is simple. Just pay attention. You call F applied minus FR. Do you understand? What's my F net? My F net is MA. But since the body is at rest, so it means this whole thing will be 0. Then if this whole thing is 0, let me not be fast. So what's my F applied? We don't know. Okay, no, we know. Because ideally, this body is meant to come like this. So mg sin theta. Minus, what's my FR? 30. Do you understand? Friction. Simple. So 30 comes here. Then let's do what? mg sin theta. Mg is already 60. So just bring this thing here. So 30 will be equal to 60 sin theta. Do you understand? 60 sin theta. So 0 cancels 0, 3 here 1, 3 here 2. So this is 1 over 2. 1 over 2 equals sin theta. So this means that my theta will be sine inverse of 1 over 2. And sine inverse of 1 over 2 in your calculator, if you are using this scientific, just press shift then sine. You get shift then sine, you get sine inverse. But if not, basically just say from your special angles, sine of what will give you 1 over 2, sine of 30. Do you understand? So sine of 30. So my theta is finally 30 degrees. So theta is 30 degrees. That's all. Very simple. It's a very, very simple question actually. Okay? Option B is correct. Good. Now, question 12. Figure above is on the board, or on your screen rather, shows a block of mass M sliding down a rough inclined plane QP at angle theta. The force acting. Ajaks. I told you. The force acting on the block. I'm serious. I never know I added this question. It just came to my mind to tell you guys this. I'm serious. So the force acting on the block along the plane QP is the plane. What are the forces responsible? Mg sin theta and frictional force. That's all. That's all. Option B is correct. Question 13. Alright, so question 13 says, appear on screen now, a bead traveling on a straight wire. So this is question 13. So there's a straight wire, alright, and a bead is traveling on it. So the bead is just moving like this. Alright, it's traveling on it. Now, is brought to rest If a body comes to rest, V is 0. I've told you time without number. Go and watch my video on rectilinear motion. Is on the screen now. Go and watch it when you are done with this one. If a body comes to rest, okay, it's brought to rest at 0.2 meters by friction. So at a point, this body was stopped. All right, the body stopped because of friction. So, and the distance it took to stop was 0.2 meters. Do you understand? Now, if the mass of the bead is 0.01 kilogram, so I'm just crossing my leg, I'm not solving. And the coefficient of friction between the bead and the wire. So this coefficient of friction now, class, is it static or dynamic? It is dynamic because the bead was actually moving. All right, so it's dynamic or kinetic. It was moving. Do you understand? So now the if the mass of the bead is 0.01 and the coefficient of friction between the bead and the wire is 0.1, so this is my coefficient of kinetic, 0.1. Determine the work done by friction. So work done, normally we already know that work done is equal to force times the distance. Sorry, not perpendicular, that's moment. So force times distance is work done. So we already know our distance as 0.2. All right, now we need to just know our force. And it said work done by friction. So this is meant to be frictional force. So Fr times the distance S. We'll get our answer work. Class, we're on a mission to find Fr. Now, how can we do find Fr? How can we find Fr? How can we find Fr? It's very simple. F net is equal to F applied minus F frictional. This is our guy. Okay? Now let's look at the question again. Let's see if they give us any clue. They said a bead traveling on a straight wire is brought to rest. Okay? Is brought to rest at 0.2 meters by friction. All right? Okay. This is actually meant to be mu s because it was brought to rest. So it means that this means our solution is 0. I mean now, so this MA is 0 equal to F applied minus F frictional. Now we're not done. So it means my F frictional is equal to my F applied. Abi, now if my F frictional is equal to my F applied, what other information can we pull out from there? What other information? Let's look. So okay now. So ideally this bead, let's say there's a bead here. Let's just put it as a block. All right. Now this bead had a weight of W. I remember it has a normal reaction of R. So there was a force that was pulling it before, which is my applied force. All right, and there was a frictional force here. So note that when a body is at rest, all right, the applied becomes the frictional. Okay, so they go interchangeably. So my applied becomes my frictional when it's at rest because F net will be 0. Then bring this one here. Now that's not business anyways. I just have to chip that in. So how can we get FR? FR is equal to, it's F applied. So let's scrap this out because they're the same thing. So FR normal is what? Mu R. That's all. So my FR is equal to, what's my mu? My mu is what I'm looking for. Coefficient of friction between the wire and the bead, 0.1 times, what's my normal reaction? So in this case, normal reaction is still same thing as the weight now. We have done that before. So what's my weight? They give us mass. They tell us that the mass is 0.01 kilogram. So it means this is mg. That's my weight is equal to 0.01 times 10. 0.01 means 1 over 100. So times 10 gives you 1 over 10. And 1 over 10 is what? 0.1 Newton. Alright? So 0.1 Newton is my weight. So this is 0.1 times 0.1. So FR will be equal to, this is 0.01. So this is my frictional force. So they ask us to find the work done. So the work done would therefore be 0.01. Are you following me? Times, what's my distance? 0.2. Do you understand? Very cheap. So W equal to 0.01 means 1 over 100 times 0.2 means 2 over 100. So this is giving me 2 over 1,000. Now 2 over 10,000. All right, 4 zeros. So 2 over 10,000 basically means I hope I'm not making any mistake because what I'm having here is different. 0.01 times 0.2, 1 over 100 times. Oh, 0.2 means 2 over 10. Sorry. So this is 2 over 1,000. Yeah, I shall know. So 2 over 1,000. Let's take this up. So what my work done be class? 2 times 10 raised power what minus 3 joules. Okay? Yes. If you take this to standard form, that's the answer. So option B is correct. I hope this makes sense. Now let's look at the next question. Question 14. So question 14, it says, you see it on your screen now, a load, let's be faster. A load is pulled at a uniform speed. That means the acceleration is 0 since it's uniform speed, right? So it's pulled at a uniform speed along a horizontal floor by a rope at 45 degrees. So this is case 4. So the theta is 45 degrees. So let's draw this diagram. So this load, all right, it was pulled. It was pulled at an angle of 45 degrees. Remember, there's a frictional force here and there's an applied force here. And this applied force is the horizontal component of this load P. Do you understand? But very, very good. They told us that if the force in the rope is 1,500, so this my P is 1,500 Newton. All right. What is the frictional force of the load? So this is what I'm looking for here. So what's my formula? F net. This formula, you see, say we don't use them since. So if you like, you swallow them. So F net is FA and my acceleration is 0. So this is 0 automatically. So it's because my F apply will be equal to what? My FR, right? Working for FR. So let's just say FR will not be equal to F applied. I mean now, and F applied, I told you in this case that F applied is the what? Horizontal component P cos theta. Go and check that thing. I told you. It's the horizontal component of this guy. So 1,5 cos 30 degrees. Okay? God, I beg. Chai! So this is 45. So root 2 over 2, please. Remember, no verse. I don't tire. So root 2 divided by 2 times 1,5. That's what. So my frictional force finally is equal to what? 1060.7 Newton. From our option, okay, approximately 1061.0 Newton. Option D is correct. Okay, good. Now let's look at question 15. All right, so question 15 says the coefficient of static friction between a 40 kilogram crate and a concrete surface is 0.25. Find the magnitude of the minimum force needed to keep the crate stationary on the concrete base incline at 45 degrees to the horizontal. So this is an incline. Let's apply what it said, 45 degrees to the horizontal. So there's a concrete base on this thing. And the base, the concrete is 40 kilogram. Don't forget there is a force here. And don't forget there is another force here. And we have established that the force here is mg what? Sin theta. Alright? Mg sin theta. And the force here is a frictional force, Fr. Alright? So, the told us that the coefficient of friction, this particular one is static. Because listen, they said, what is the minimum force needed to keep the crate stationary? That means they want the crate to be stationary, it should not move. So my MUS is 0.25. Alright? Now, what is the minimum force? What are we looking for? First of all, what are we looking for? We are looking for the minimum force to make sure that this crate is stationary on this whole thing. It means that this particular body must be in equilibrium for it to be stationary. And for it to be in equilibrium, the minimum force needs to be the net force. So F net is equal to F applied minus F frictional. Are you following me? So what's my F applied? They not tell us, Abby? They not tell us. So my F net, since it's stationary, okay, no, hold on. Let me read this question properly. Okay. They did not say the body is stationary actually. This is K. I'll tell you why they did not say it's stationary. They said, what is the minimum force that's needed to make it stationary? That means initially this body is just trying to come down. So what force will make it stay still is what we're looking for, F net. And in this case, the applied is like this. And what's the friction now? Yeah. Right? So let's divide this body into 2. Are you following me now? My F net again, which is what I'm looking for. What's your M? M is 40 times G is 10 sine 45 degrees minus FR. Now let's find FR somewhere here. FR, we already know that is mu. So this is mu KR. Are you getting it? So my FR, you know this is no mu S, because if it was mu S, then this F net is meant to be 0. Because FA is 0. A is 0. So that's this mu K. Now, 0.25 times R. Now, class, what is R on an incline? R is what? mg cos theta. Alright, so let's compute R here. What's mg? Let's compute R together. Everybody, go to your calculator. What's m? The mass is 40. What's g? 10. What's sine cos 45? Cos 45 is same thing as sine 45 anyways. So what we can just do, let's calculate. So cos 45. So this whole thing, okay, so this whole thing now is what? 282.8 Newton. So please, I hope you all got this thing. M is 40, G is 10, for theta is 45. Please try it on your own. Okay, let's continue. So now my FR will be equal to 0.25 times this thing, 282.8. All right, so multiply. FR will now be equal to what? Times 0.25. That's 70.71 Newton. So this is my what? Frictional force. Are you getting? So this is my frictional force. So you bring this one here. So my F net will be equal to, let's compute this whole thing. This one here. 40 times 10 times sine 45. Try it. You will give us the same thing that we got here. So you, because sine 45 is something as sine 45 something as cos 45. So this is mg, 40 times 10 times sine 45. Same thing we did there. You can try it if you don't believe me. See as you're looking at me. Minus, what's my FR? 70.71. So what's my F net, which is my minimum force? Subtract 282.8 minus 70.71. 212.09 Newton. Option D is correct. Friction. It's not anybody beat. So I hope we all understand what I just finished doing. Okay, they said the minimum force. So the minimum force is basically the net force. Do you understand? Because we need that force that will be responsible for this body to be in equilibrium. And for you to say equilibrium, the conditions for equilibrium is that the condition for equilibrium is that the summation F, whether x or y, that's whether I'm doing vertical or horizontal. Let me just see summation fx must be equal to 0. So you have to find summation fx here, and that's basically just taking the net force in this whole thing. I hope this makes a lot of sense. Now let's look at question 16. All right, so question 16 we are playing on the screen now. Welcome back. So question 16 says a box of mass 40 kilogram is being dragged along the floor by a rope inclined at 60 to the horizontal. The frictional force, let's just draw. So a box of mass 40 kilogram, all right, is being dragged. So this is my horizontal. So the box is being dragged along the floor by a rope that is inclined at 60 degrees to the horizontal. The frictional force between the box and the floor is 100. So this is 100 Newton, my frictional force. And the tension on the rope is what? 300 Newton. How much work is done by dragging the box through a distance of 4? So my work is working for, and work is force times distance. Class, what's the force they are asking us to find? The force they are asking us to find is the net force. Yes, times the distance. Because the other question that they asked us to find force, the question specifically stated that what is the work done against friction? Now, this one said the work, let me read again. It says the work is done, how much work is done by dragging the box through a distance of 4. That means we have to find the net force in this question and multiply by the distance to get the work. So it's very simple. All right, it's very simple. What's my net force formula? My F net is equal to F applied minus F what? Frictional. So my net force, which we're working for first, is equal to, what's my F applied? This thing here. And I told you that in this kind of question, F applied is the horizontal component of this tension. So that's T cos theta. That's cos 60. Minus FR. So what's my F net? My F net is equal to, what's T? 300. 300 cos 60. Cos 60 is 1/2. Minus, what's FR? 100. So F net finally is equal to, this is 300 times 1/2. That's 150. That's 150. Minus 100. So what's my F net? My F net will be equal to 15 Newton. Now my F net is 15 Newton. Then they ask us to find the work done. So my work done is equal to 50. That's the force times the distance. They say it travels for what? 4 meters. Let me show. Yes, 4 meters. So what's my work done, class? 200 joules. Option C is correct. Okay, so I hope this makes a lot of sense and I hope you are learning. Please ensure to like, subscribe to this channel. Now let's look at question 17. Question 17 says, appear on screen now, a concrete block of mass 35 kilogram is pulled. So it is pulled, a concrete box of mass 35 kilogram is pulled along a horizontal floor. Pulled. And with the aid of a rope inclined at 30 degrees. So this is the block. The block is 35 kilogram. So it's pulled. You can see questions like this come out in JAMB a lot. It's pulled at an angle of 30 degrees. So it's pulled. Okay. Then there is a frictional force here. Because it said if the coefficient, so this is my frictional force. So if the coefficient of friction, right, so now I went back to check this question because I noticed that there was no it did not state whether the body is at rest or not. So the question actually said if the coefficient of static friction is 0.75. So my μs is 0.75. Now, if it is static, what does it tell you? It tells you that my F net is 0 because my acceleration is 0. So let's do normally, what will F net be? Normally F net is equal to F applied, that's this one, minus F frictional, that's this one, right? So this is 0 equal to F applied minus F frictional. Finally, F applied will be equal to what? F frictional. Now, we have to take it step by step. We have established that F applied is equal to F frictional. Then now let's solve. Let's solve. So my F applied from this particular question is they told you that this is my angle and this is my force, right? The force used to pull. They don't even tell you anything about the force. Okay, we'll find that. So F cos theta, right? This horizontal component is F cos theta. That's F cos 30. So my F applied is F cos 30. Put that in your mind. Now let's find my FR, F frictional. Normally F frictional is mu SR, right? But in this particular case, I told you that we have to account for, my normal reaction is here. You have to also account for the what? Upward F sin theta here. I told you this was case 4. So my normal reaction, this mu SR is equal to 0.75 times R. And what is R on its own? R on its own is, so FR equal to 0.75. R on its own is, from this whole thing now, we have that the upward forces, that's R plus this one, F sin theta, is equal to W, the weight. So we have that R is W minus F sin theta. I hope this makes sense. So W minus F sin theta. Now, my FR will now be equal to 0.75. What's W? 350. Minus F. What is my sin theta? That's sin 30. So this is my R. This is my FR. So this thing is equal to this thing. It means that this thing, 350 minus F sin theta, will be equal to what? F cos 30. Now, from here we can solve for F, because the question asks us to find the force required to move the block over the floor. So that's the pulling force. To move it over the floor, it means that's the pulling force. So I'll give for this F. And from here now, we can find our F. Yes, we can find our F. Sharp. Let's follow me. We can find our F from there. Now, follow me. 0.75. I'm writing this again so that we can see. 350 minus F sin theta equal to F cos 30. Right? So from there, let's find our F. Now, this divided by this. So 350 minus F sin theta, that's sin 30, is equal to sin. Let's find cos 30 first. Press your calculator, class. Cos 30 is 0.8660. So divide cos 30 by this one. So that's cos 30 by 0.75. This gives me 1.154. F. Don't forget. Are you following? Now, this 350 minus this is 0.5 F equal to 1.154 F. Bring this one here. 1.154 F plus 0.5 F. This gives me what? 350. Are you following? Now, this thing here, let's add it. Plus 0.5. This gives me 1.654 or 655 approximately F equal to 350. Class, what's your F? 350 divided by what? 1.655. 350 divided by what? 1.655. 212 Newton. Yeah, that's it. 212.8 Newton. Option C is correct. So that's basically it. I hope we all understand. It's very simple. The question was basically telling that, okay, there was a block and we have to find the pulling force. The force that we require to pull this block over. And we know that this is P cos theta. Alright? And this was my F, frictional force. And because it was static, alright, that means this and this are equal. Why? Because F net is 0. From there you solve. That's it. So I hope you understand. And my last question is question 18. I'll give you guys, I'll put it on the screen now. Try it. And let me just tell you, it's very simple. They say that if the body is sliding down, what will be the acceleration? Simple. As it's sliding down, mg sin theta will be applied force minus the frictional force equal to ma. Now, m is given, a is not given. You solve. So put it in the comment section now and attempt these 2 more questions, altogether 3 assignments. Okay? So yeah, we have come to the end of this video, and I hope you all enjoyed the video. So if you're a WEC student, JAMB student, post-UTME candidate, depends on when you're watching this video, this is my number on the screen. Text me on WhatsApp to be part of our paid classes, and you can get more of video tutorials like this in Ajaks tutorials. Okay? So have a lovely day and bye.